Atomic mass problems. Number one is done for you, and let me explain what it is that they're doing. If you notice on the periodic table, the atomic masses are never whole numbers. They always have numbers after a decimal point. I guess there are some exceptions down here. These are radioactive elements that don't stick around very long, so these are on kind of an average about what they tend to be before they disintegrate into nothing. I shouldn't say nothing, they do break apart though. On these, what we're trying to do is figure out the average atomic mass, just like they did for this periodic table. So if you notice, for nitrogen, our average atomic mass is 14.007. Not all atoms of nitrogen have a mass of 14. Some of them are greater than this, but as you can notice, it's going to be a very small amount of them are greater than this because this is an average of all the different isotopes of nitrogen. Isotopes are just atoms with different numbers of neutrons in them. So most nitrogen has a mass of 14, so 7 protons and 7 neutrons to make a total of 14. But some atoms of nitrogen do have extra neutrons in them, but not very many, which brings our average up a little bit above 14. So what we're going to do in our problems here on the worksheet is determine the average atomic mass of certain elements based on their isotopes and the percent that we find them in. So you can see boron 10, we only find 19.91% of boron has a mass of 10. 80.09% of boron has a mass of 11. So to find the average atomic mass, all we do, we take the mass of each isotope, 10 and 11. So here's 10 and here's 11. And we're going to multiply by the percent. Remember to put percent back in decimal format to multiply. We just move the decimal 2 places to the left. Make sure for all of these problems you move the decimal 2 places to the left before you multiply, or you will end up with the wrong answer. So move that 2 places to the left. We end up with 10 times 19.91%, which is 0.1991. We have 11 times 80.09%, which is 0.8009. We add these together because 19.91% is a mass of 10, 80.09% has a mass of 11. When we add those together, we're going to get our total answer. And as you see here, 10 times 0.1991 is 1.991. 11 times 0.8009 is 8.8099. Add them together and we get an average atomic mass of 10.801 AMU. The best way to check this and make sure that you've done it right is that your average atomic mass should be somewhere between your lowest and highest isotope masses. So if you end up with an answer that is below 10 or above 11, go back and recheck your math because that means you found the wrong answer. So some of these only have 2 isotopes just like this one does. Once we get down to number 5, notice it says sulfur exists as 3 isotopes. 95% of sulfur 32, 0.76% sulfur 33, and 4.22% sulfur 34. So be careful on these. You're going to do the exact same thing as you did up here at the top, but now you're going to do this plus this plus this because there are 3 isotopes. So you do it 3 times instead of twice. Here we have 5 isotopes, 6 isotopes. Also, you'll notice on number 8, it gives us all of these percents. Percent, 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 and it says, and the rest has a mass of 315. What do all of our percents have to add up to? Percents add up to 100. 100% is the total. So I'm going to take all of these percents that I have, add them up, and figure out what's missing from 100. So if I add these up and subtract my answer from 100, I'll know what percent to put here as the rest. So you're going to plug in this percent here that you get and use that as the percent you multiply by 315. There are questions just like this on your test. Make sure you understand how to do them. If you still have questions, please come ask.